So here's an overview of how factoring works. Remember, the first thing you want to do when you're factoring is look for the greatest common factor, which we did in the last video. If you can bring out a greatest common factor to start off with, you want to do that. And also look for polynomial identities, which we'll talk about later. And then after that, the way you factor depends on how many terms the polynomial has. What we're going to focus on today are 4-term polynomials. So here's kind of the general steps that you can follow if you want to write those down in your notes. We call this the grouping method, and it works for 4-term polynomials. So let's go through a few examples. See how this has 4 terms? So first I'll look and see if there's a GCF. Could I divide all the terms by the same thing? And I can't here, so we'll just jump right into 4-term stuff. The first step is to group the first 2 terms and the last 2 terms. So just group these 2 together and these 2 together. If there's a minus, that needs to stay with the 4x, but note that you are adding these. This is not multiplication. It's like plus a negative 4x. Okay, the second step is to factor out a GCF from both groups. So look at this first group. The GCF that we could use would be a 9, because you could divide them both by 9. And then we could also bring out an x squared, because they both have at least an x squared. In parentheses, I'll write down what's left. After I divide this by 9, it's just a 1. And I had x cubed, I took out x squared, so now it's just x left. Then 36 divided by 9 leaves a 4, and x squared divided by x squared is just a 1. All right, let's try the second group. On this second group, I could divide by a 4 or maybe a negative 4. So here's what you want to be careful of. By the time you factor out a GCF from the second group, you want to have left over the same thing you got in the first group. Basically, you need this and this to match. And so in order to do that, just factoring out a 4 isn't going to be good enough, because then I'll have negatives left here. So what I'm going to try instead is a negative 4. If I divide this by negative 4, I'll get an x. And if I divide this by negative 4, I get 4. And so now this matches this, which is exactly what I wanted. So that was step 3, make sure the remaining terms match. And whatever you get there, that is one of your factors. So this x plus 4, that is one of the factors. I know it's written twice, but it's just one factor. And then the other factor, and this is step 4, comes from combining what you have left, the 2 GCFs. Combine this with this, and you get 9x squared minus 4. So this is my factored version. I have 2 things that multiply together to give me this expression. So those are its factors. As a bit of a side note, you could keep factoring this one right here, but we'll pause on that for now. All right, I want to explain a bit where this is coming from. The reason we only put down the x plus 4 once is because basically what we're doing is we're treating x plus 4 like a GCF. Like, imagine this is all one term, and imagine this is all one term, and they both share the x plus 4. So basically, you factor out an x plus 4 from both of those pieces, leaving 9x squared minus 4. So it's almost like you're bringing the x plus 4 out to the front like a GCF or something. All right, let's try another one. You may be tempted, since this one is 4 terms, to jump right into grouping it. But be careful, this one has a GCF. So we're going to want to factor that out first. It has a GCF of 2, because we could divide everything by 2. So when I do that, that's going to leave 12x cubed minus 3x squared plus 4x minus 1. I just divided everything by that 2. All right, now we're going to do everything the same as we just did, but that 2 has to hang out in front. I like to write it down here so I don't forget it at the end, because sometimes I do that. So this is a 4-term thing. We're going to group the first 2 terms and the last 2 terms, and basically ignore the 2 for now. It's just going to stay in front. Now I'll factor out a GCF from both groups. So what could I divide both of these by? That would be a 3x squared. Because 12 divided by 3 is 4. And if I had x cubed and I took out x squared, I have 1x left. Negative 3x squared divided by 3x squared is a minus 1. All right, this one's going to be a little weird. In this group, there's really nothing that I can factor out. There's no GCF. But I do have to have something here to combine with 3x squared, so we're just going to put a 1, because 1 times anything is itself. The only thing I can factor out is a sad little 1, leaving 4x minus 1, which is good because this matches this. That's one of my factors. The other factor comes from combining the 2 GCFs, 3x squared plus 1. And those are my 2 factors. Oh, I almost forgot. The 2 that we factored out from the very beginning needs to stay up front. So just put it right there in the front, not in the parentheses, just in front of the parentheses. If you didn't factor out a GCF to begin with, what you would end up getting is something like this. This isn't wrong, it's just not finished. Notice that this has a GCF of 2, so you would at this point need to factor out that 2 and get back to here. So it's okay if you do it at the end, but it's easier at the beginning, I think. All right, let's try another one. This one doesn't have a GCF at the beginning, so we'll jump into 4 terms grouping method. Group these 2, group these 2, and then what can we factor out from this first group? 2 and 3 are not divisible by the same thing, so all we can factor out is an x squared, leaving 2x minus 3. On the second group, again, we can't really divide by much of anything, so maybe we'll try putting a 1. But if we do that, notice this doesn't match this, and so we're going to need to try something else. Instead of a positive 1, let's try a negative 1. Because if I do a negative 1, now what I have left is positive 2x and negative 3. If you divide by negative 1s, you'll get this. Okay, now this group does match this one. That's one of my factors. And the other factor comes from combining the GCFs, x squared minus 1. This is another one of those where this would actually keep factoring. It would keep breaking down, but for now we're just going to stop there.